FSPro Winds. This short video will provide information about the Winds page in the FSPro Fire Behavior Model and will include selecting a time filter, wind type, generating the wind matrix, and reviewing and editing the matrix. Fire spread probability, or FSPro, is a useful tool in assessing probable fire impacts in the long term. As with many models, however, quality inputs are needed to produce quality outputs. In this video, we will discuss the Winds page and the user selections from this page. Winds is one of the required inputs before an FSPro run can be made. To view the Winds page from within an FSPro run, select Winds from the left-hand menu. You will notice that initially a weather station is selected from the drop-down menu, in this example, the teapot station. This is just the default station based on proximity to fire origin and should be evaluated and changed as needed. See the video, Weather Station Selection for FSPro, for information about the items to consider while selecting a station for the FSPro Winds page. Selecting a station is just the first step on this screen. Remember, the goal with station selection for FSPro Winds is to utilize a station that best represents the winds the fire area is likely to experience. After you have selected one, you must then choose the date and time filters to narrow your wind data in order to tailor it to the current fire conditions. Let's begin with start year. The minimum years of data a station needs to be available for selection for winds is 5 years. However, more data years is often better, provided the data is of good quality. The more years that are used in the filter, the more years of possible wind scenarios you will have in your simulation. However, do keep in mind that more is not always better if the quality of the data is poor or has large gaps. Utilize Fire Family Plus and local fire resources to tell you about station history. Next, you will want to narrow the start month and day for the wind data. The default filter is set for approximately a 6-week window, 2 weeks prior to the analysis start date and 4 weeks in the future from the analysis start date. The purpose of the month-day filter is to limit winds to those that are likely to affect the fire area. For example, in many places of the country, there are distinct wind patterns for the different times of year. The goal is to select a time period that defines the winds likely to affect the fire area. Often, the 6-week window is adequate. However, if you would like to make adjustments, type over or use the calendar symbol to choose a different start date and end date. Similar to the goal with the month and day filter, the goal with the start hour and end hour filter is to narrow the data to capture the winds that are affecting the fire area. Ask yourself, what time of day is the fire burning? When do we see the most spread? On many fires, winds die down at nighttime and spread is limited. Therefore, if we included nighttime winds in the simulation, we might underpredict the possible wind speeds that are affecting the fire. However, this is of course not always the case. Some fires spread actively at night under influences of localized nighttime wind patterns. Seek to set the time filter to best capture the winds that the fire is likely to experience while the fire is spreading. Under the next heading, Weighted Winds, you can see that we can change the wind type from 10-minute average to gusts or to both 10-minute average and gusts. 10-minute average is the default, and utilizing this selection will provide data from the 10-minute average values. Selecting both will increase wind speeds and includes a greater representation of higher wind speeds. Selecting gusts is also an option, but this should be used with caution. Selecting gusts may only cause the model to overpredict probabilities. When determining which type to select, consider a few things. If you have completed any near-term or short-term simulations utilizing this station, how have those wind values worked to model past and predict future spread? Have you consistently had to increase the station winds to produce observed fire spread and conditions, or have they worked well? Is the station possibly sheltered and the recorded winds potentially lower than what you think the fire might experience? Be cautious when choosing either both or gusts. Consider creating 2 FSPro simulations if you have time, one using 10-minute winds and the other using both winds, and compare the outputs. If the station is in a good location to detect winds on the fire, likely the 10-minute average winds will suffice. At this point, we can go ahead and select to generate the wind matrix. The wind matrix takes all the wind data within the filtered dates and times and lumps it into varying speeds and 8 cardinal directions. For example, for this station, the teapot station, with the filter year, month, days, and times showed, the wind is 3 miles an hour from 45 degrees approximately 1.39% of the time, and 3 miles an hour from 90 degrees approximately 2.31% of the time, and so on. Keep in mind that the value in the calm weight setting, in this example, the calm weight, which is defined here as 1 mile an hour or less, occurs 11.17% of the time. This means that of all the hundreds or thousands of simulation days for this analysis, 11.17% of the time, the wind will be calm. Consider this value when making a final station selection. If the calm weight wind is fairly high, it could just mean that the station is not in a very windy area, and that's okay if that will be representative of the fire area. However, it could also mean that the station is very sheltered. If the fire area is not likely to experience high amounts of calm winds, you should consider selecting a different station if one is available. Usually, local fire personnel and/or the station owner can help with this assessment. If you were to add up all the percentages in the wind matrix and the calm wind weight value, they would equal approximately 100%, shown here under total weight. It can be difficult to look at this chart and decipher speeds, directions, and percentages and determine if they seem appropriate for the fire area. A good graphical way to look at the data is to select the wind rows button. The wind rows will display the same information in the matrix chart, but in a graphic. It's very easy from this graphic to see that although the station does experience winds from all directions, there is a greater amount of times when the winds are from the west, northwest, and southwest, and wind speeds are generally higher from those westerly directions as well. Keep in mind, this graphic reflects the time and day filters you apply to the data as well as the wind type. For quick comparisons between filter and wind type settings, you can view the wind rows outputs from different filter settings to get a good picture of what the inputs will do to your simulation. You can also view all the wind data in an Excel table by downloading the wind data from the Download Winds button. If you do decide that you need to edit the wind data because there is not a station that will represent the historical winds for the fire area, you can do so, although caution is advised. Keep in mind this data represents the historical wind for the area over many years. Values can be edited by typing over the current values. You can also utilize the Add Row or Delete Row buttons to further limit or expand the wind data. If you do edit the data, keep in mind the total of the wind percentages and the calm weight should equal 100% approximately. So if you are shifting values, make sure the adjustments are adequate to keep that balance. When you have the wind inputs set as desired, select Save to save the wind values at the bottom of the screen. It's a good idea to utilize the Notes section to capture information about the selections made to the wind screen. For example, why you selected the filter period you did, or why you selected a certain wind type. To do this, select Notes from the left-hand menu. Type your comments in to the open box and select Save. To review, in this video, we covered selecting a time filter, wind type, generating the wind matrix, and reviewing and editing the matrix.